This is the second video that covers the parts in the caster assembly for the first assignment in parametric modeling. We did the revolved parts in the last one, so what we'll do now is the extruded parts. We'll start with that top plate. So once again, I'm going to go back over to SolidWorks. Just going to get rid of that. Now we'll start a new part. Part file, OK. Make sure that inches is changed to millimeters. Come back out. We're going to do a sketch by picking the sketch tab, and then we're going to pick the sketch tool. Sketch is also going to be on the front plane. And I'm going to start with a center line vertically because this part's symmetrical left to right, so we're going to draw half of it and then mirror it over. Start by drawing a line. Come in and just rough out the shape. Again, it's been really nice since SolidWorks has made it possible to sketch anything without having to worry about how big it is, because your first dimension will scale the sketch automatically. We're going to mirror entities. Capture those entities. Pick mirror about. Pick the center line. Mirrors about here. So now we can just go ahead and throw in our smart dimensions. Smart dimensions, do the overall length first. Smart dimension, the overall length is 136. Distance from here to here is not how it's dimensioned on the part, so I'm going to go and dimension it instead from here to here. That's given as 4 millimeters. And we'll just get rid of that dimension altogether. Yeah, the overall width is 16. So we'll go back to smart dimension, indicate the overall width of this part, 16. It's also 4 millimeters from here to here. Bring that out and put in the 4. Now the distance from that line to that line is given as 60. And the distance from here to here is given as 44. Because we mirrored the parts symmetrical, it's going to be make a change in both places. We now have a fully defined sketch. Now in this case, we're going to go to features. We're going to do extruded boss, but we're not going to just extrude it blind. We're going to extrude it mid-plane because this part is symmetrical in both directions. So I'm not going to do an extrude that'll leave the origin on one side or the other. I want the origin right down the middle. So it'll be mid-plane. I just put the overall width here, which is 82. Now it comes out from the middle, and so the origin is placed where I want it to go. Click the green check, and now I have most of that part. Now if we take a look at that, there's some holes and there's some fillets, and it appears that the holes and the fillet share the same center. However, that whole pattern is more significant than the radius of that fillet. It's actually round. So even though they are in fact centered, I'm going to start by putting the holes in, and then I'm going to add the fillets later. If I put the fillets in and then added the holes so that they matched up the fillets, a change in the size of the fillet would change the location of the hole. So I'm going to use Hole Wizard for this. Hole Wizard is on the Features tab. I'm not in a sketch right now, but it'll come up and give me two tabs, one of which allows me to go to a sketch, which is a Position tab. I'm going to place my hole here, and I'm just going to put one hole there. I'm just going to put it in place, go to Smart Dimension, then indicate that the distance from here to here is 12, and the distance from here to here is also 12. That locates the hole, and now I'm going to use the mirror command in Features in order to make sure that this part's always symmetrical. Get out of Dimensions, go back over to the hole type. We're going to do a through hole here. It's going to be ANSI metric. The size of the hole is down here. Now, dowel holes, drill sizes, just gives you some different choices. If I come down here to dowel holes, you notice 11, which is the size of the hole I want, isn't there. If you try drill sizes and go down, drag down, you'll notice that the 11 is there. So select the drill sizes so 11 shows up. If it doesn't show up, you can always change the size by showing custom sizing. Now I have to determine what the end condition is. I'm going to select up to next, which is means it's going to go until it hits that point, as opposed to through all. Now I've just got the one hole. Now the reason I have that one hole is what I want to do now in the Feature tab Now, not the sketch tab, the feature tab. There's also a mirror command in the feature tab. It's right here. And what I'm going to do is to mirror that hole around the plane that goes down through the middle of the part. The reason there's a plane that goes down through the middle of the part is because I drew it with the origin located in this sketch. So that's the right plane. The feature I want to mirror is going to be that hole. Pick OK, it mirrors it over. Now I'm immediately going to mirror again because I want to mirror this time around the front plane. The last thing I selected was the mirror I just made, so it'll mirror the mirror. Now those holes will be spaced properly and symmetrical whenever I make a change to the overall size of the part. Now I can go to the fillet command, indicate I want to fill it with a size of 12, which I change over in the properties manager. Pick each one of those edges. I need to pick right through the part. Pick the green check. Now the top plate is done, fully defined, and ready to pass in. And by the way, if I go over and open up in the feature manager, the Boss Extrude, the sketch that shows up underneath it, which it was based on, does not have a negative in front of it. That means it's fully defined. Same is true of the two sketches that resulted in the hole being created. Now the only thing left to create here is the only thing left to create here is the axle support. The axle support's right there. There's a couple of ways to do this. One involves just creating the outside shape of the part and then adding each of the features separately. The other is to have one sketch that has all the features sketched out in it, and then to use the contour method for extruding. I have a video on using the contour method for this, so this one I'll call the conventional method. So we go to SolidWorks. Once again, start a new file. Make sure it's set for millimeters. Go to the sketch tab, go to the sketch button. We're going to sketch this on the front plane as well. I'm going to put a center line. I want that center line to go vertically down through the part because it's got symmetry side to side. Does not have symmetry up and down, however. So I'm going to start by using a line. It starts on the origin, to place the origin at the top edge of the axle support and right in the middle. Come over, come down, and I'm going to stop now. Now what now is an arc on the bottom. There are a couple ways to put that arc in. I find that the way to make sure that it really is what you want is to start by drawing a circle. Put the circle in place, then draw a line that goes from the end of this line down to the circle, and just move your cursor until you get two cliffs. And you can see I have right now just one. Now I've got two. One of them, the first, indicates that we have a coincident relationship, so that means the end of this line will touch the circle. The other means we have a tangent relationship, which means the line will always be tangent. If I go off a little bit from the tangent, now I've got a coincident relationship that won't always be tangent, and that could cause a problem. So I'm going to wait till I get this, which, by the way, you can always add that if you want to. Once again, we're going to mirror the entities, but don't mirror the circle. Just mirror those lines right there. Mirror about. Come over here like that. Now we're going to use the trim function. Power trim allows you to just drag through the area you want trim. There's our basic shape. We'll start dimensioning it now, and I'll start in this case with the overall width. And the overall width from here to here is 82. Then I'll indicate that that dimension is 10. This is 19. And the distance from here to here is 48. Now we have a fully defined sketch. So what I'm going to do now is to do an extruded boss. And I'll just have it come out in that direction. This also has a thickness of 10. Now we're going to add the other two features. I'll do a sketch. This time I'm going to do the sketch not on one of the actual planes, but I'm going to do the sketch this time on that surface right there. And I'm going to use the rectangle command, which is right here. But I'm not going to use the center rectangle. I'm going to use the corner rectangle because I know that the part that comes out always has to match that size right there. I have a fully defined sketch with no dimensions because the coincident relationship between the corners defines it. Now I go to features. I'm going to do an extruded boss and base and have it come out. Now if you take a look at the drawing The drawing shows you that it's 38 millimeters from the back surface, not from the surface I sketched on, but from the back surface all the way out, 38. In order to accomplish that, what I'm going to do when I do my extrusion is, instead of starting from the sketch plane, I'm going to say start from a surface that I select, and it's going to be that surface right there, and then make it 38. Now I've built in my design intent, which is to make that 38 from the back surface without doing any math. If later on I would have changed the width of this, it's still going to be 38 from here to here, which is the dimension that I want to maintain. Now we have the part that comes out here, and we're going to put that little raised boss over there. Do another sketch on that surface. I'm going to draw a circle. I'm going to hover over the arc until the center shows up so I can snap to the center. And now I want to snap to that point right there. And I have a coincident relationship to that point and a tangent relationship. The reason I want to do that is because I don't want this raised boss to be a different size than the radius at the end of the axle support. Now again, I didn't have to put any dimensions on here. As the size of that arc changes, the size of this raised boss is going to change as well. It is a fully defined sketch, it tells me right here. This time when I do an extruded boss, I'm going to do it from the sketch plane. It's going to be blind, and it's going to be, I'm sorry, it won't be from the sketch plane. I just took a look at the part. The way it's dimensioned is it actually gives a distance from that surface as 12. Again, I could have done a raised boss of 2, which is how I probably would have done it, but that's not how the dimensions were given, so we're going to use the dimensions as they were given. Now this is why I didn't bother to put the hole in when I made my first sketch, because I had to add that boss, and if I had done that I would have the hole would be blocked. So I'll go back to sketch, sketch on that surface, we'll do a hole, again we'll hover over the edge of the part. When I get the center showing up, I can now snap to that center, come out, put a dimension on this, put a dimension on this. The dimension of that hole is 19. No, it isn't. The dimension of that hole is 22. Now I'll do a extruded cut. The extruded cut's going to go up to next. Click OK. Now we have most of this part done. Put a couple of fillets on the corners. One goes here, one goes here. The size of those fillets is 12. Do that. And we have a couple of holes to put in. So we'll go back to our hole wizard. Put the holes on this top surface. I'll position it here. If I look at the type, yeah, we've drill size is 11. It's the same as the one we did before, and that's actually the size we want that. We do want a spot face on the back side of it, however. So we could do this by using the spot face of the counterbore symbol, in which case I'd want to place the hole on the bottom. Okay, so we'll do the hole wizard again, just to show you how that's done. Okay, we'll do the position. Position is going to go right here. We'll do a dimension on it. Make sure that the dimension from here to here is 12. The dimension from here to here is also 12. Okay, now we're going to go back over to, get out of the dimension command, we're going to go back over to type. This time we're going to do a type of counterbore. Now we're going to come down and use custom sizing, because it does give us some sizes that wouldn't normally come up. So it's an 11 millimeter spot face, and we'll be able to control the depth here as well. So the hole itself is 10 millimeters. Oh, I'm sorry, the hole itself is 11 millimeters. Spot face is 20 millimeters. Looks like that. And the depth, let's just make the depth 1.5 millimeters. This has to be deep enough to get down below the surface of the cast part. Click OK. Now we have a counterbored hole that represents the spot face. Now I'm going to mirror that, even though I could have put two holes in at the same time, but I am going to mirror to make sure that the part stays symmetrical. So we're going to the mirror command, going to mirror out the right plane. It was already selected, last thing we created. Now we've got a kind of put holes on both sides. Now the last thing to put on here is a fillet. We'll put a fillet on. The fillet's going to have a diameter, a radius of 3. And you'll notice that as I start to pick the fillet, it'll put it in until it doesn't. Because what I've done right now is I've made a really, really difficult corner by picking those two. Well, I also know that if I pick that point right there, it will actually give me what I want, because once it doesn't have a sharp corner here anymore, it can go all the way around. Sometimes you have to practice a little bit with filleting in order to get it to work, but that gives me the fillet all in one pass. And the fillets on the other side are also 3 millimeters. So if I'd like, I can come over this other side and start filleting as well. Pick that point, and then I pick this. Now you notice that gives me the same problem. So what I'm going to do, I'm going to leave these for another fillet. We're going to just use that one side, pick the green check, and now I'm going to go back in the fillet command. And I'm going to go back in the fillet command and try it from here. So sometimes with fillets you have to experiment a little bit. So we'll do this a little differently. This time I'll do the fillet that goes down here, the fillet that goes down here, and then I'm just going to get out of that. Now those fillets are in place. Now I'll do a separate fillet of this, and I think it'll work. It does. So now we have the part completely done.